All right, so we're going to do recap for BCR 3.1, and this is all understanding chemical reactions. So the first thing is, what is a chemical reaction? So a chemical reaction is when we affect the electrons. So more specifically, the valence electrons. So when we bond things together or we break apart those bonds, that would be dealing with your valence electrons, therefore it's a chemical reaction. Things that we could witness in a chemical reaction, fizzing, bubbling, meaning there's production of gas. There could be color change, pH change, temperature change. That's a big one. That's what we're going to see in the next objective. I don't know if I said fizzling already, but you can smell odors, different things like that. So the next thing that we'll talk about is being able to identify reactants and products. So if we have a chemical reaction and we have the equation, they're always looking like this, and they're separated by the arrow. The arrow represents that there is a reaction that occurred. Your reactants is always on the left and your products is always on the right. Now the thing to remember with this is whatever we have to start with is not really anything like what we end up with. We end up with new substances. Not that new matter is created, okay, because that's not happening, but the matter that you have is totally different from before. So like for example, we have water here, or phosphorus pentachloride, okay? When we go over here, we have hydrochloric acid, totally different from water, or trihydrogen phosphate. Again, you probably don't know that, and that's okay. But these are two totally different things. So yes, we have the same amount of matter, we have the same types of atoms, however, they are nothing like they were from before, okay? So the next thing that we're gonna do is we're gonna talk about the law of conservation of mass and how it relates to here. So the law of conservation of mass, kind of what we just hit on, is that you can't create or destroy matter, you can only transform it. And how we're gonna do that is we're gonna take a look at balancing this equation. So whatever atoms I have on the reactant side has to be the same as the amount of atoms on the product side. In the previous lesson that we had for 3.1, we did kind of picture models, and then I showed you guys the checklist. I'm gonna do the checklist for this one to balance out, just because I think it's easier, especially with more complex equations. So the first thing that I do is I create a reactants and products chart, okay? And then I list my elements. I always list them from left to right, and phosphorus and chlorine, hydrogen and oxygen, okay? So I have all of my elements, they're the same elements on both sides. Now I'm going to count up how many of each I have. So phosphorus, over here I have 1, chlorine I have 5, hydrogen I have 2, and oxygen I have 1. Now if we go over here, phosphorus I have 1, chlorine I have 1, hydrogen I have 4. Remember, it's total amount on that side, and then oxygen I have 4 as well, okay? So now, just by looking at this chart, we can say definitely not balanced. If it was balanced, 1, 1, 5, these would match up all the way down. So the next step we have to do is we have to put coefficients in here to make this balance. So what I'm going to do is I'm going to start from the top, again, work my way down. We see that phosphorus is balanced, so therefore I'm going to skip phosphorus, and I'm going to go to chlorine. So if I want to get out chlorine, I want to try to balance these two out. Okay, there's 5 chlorine over here. I want to try to get 5 over there if it's possible. Well, it is. All I have to do is put a 5 here, okay, and if I put a 5 there, that then changes my chlorine to 5, because 5 times 1, but it also affects my hydrogen, because I have 5 here plus another 3 here. So that means I have got to change this to 8, okay? So phosphorus is balanced, chlorine is balanced, hydrogen's not balanced. So we have 8 over here. We want to try to get this maybe to 8 if possible as well. So to get that to 8, I would need to then put a 4 here. If I put a 4 here, 4 times 2 gives me 8 hydrogen. But then it also affects my oxygen. 4 times 1 gives me 4, and then actually that works out great. So 1 phosphorus, 5 chlorine, 5 chlorine, 8 hydrogen, 4 oxygen, 4 oxygen. This now is balanced. If I wanted to put 1s here as placeholders, I could, but you would never see that necessarily in chemistry, because just like 1x, you typically don't see that as well in algebra. All right, so that's the first example. Let's go to the next example. All right, our next example, same idea. We have, whoops, I just dropped you. My bad. What just happened? Sorry, that's not awkward at all. Let me check to see if that's good now. Sorry. Little bit of an issue there. Okay, so now we have iron and water reacts to form iron oxide and hydrogen gas. Again, these are 2 totally different things. Same elements, but 2 totally different things. So we're going to, again, create our reactants and products chart. Our reactants and products. Reactants are always on the left, products are always on the right. We're going to list our elements, Fe, which is iron, hydrogen, and oxygen. We only have 3 elements on both sides. Okay, iron, there's 1, hydrogen 2, oxygen 1. Over here, iron 2, hydrogen 2, oxygen 4. Okay, now again, starting at the top, working your way down. If we have iron 2 over here, we can make this a 2, and then that would change that to a 2. Okay, hydrogen's already balanced 2 and 2, so we can skip that. Let's go to oxygen. If there's 4 over here, I want to try to get 4 over here. So if that's the case, I'm going to put a 4. And if I put a 4 here, that makes 4 oxygen. Well, that's kind of screws up our hydrogen, but that's okay. So now hydrogen becomes 8 here. And then, all right, oxygen's balanced, but we got to go back to hydrogen now. So if we go back to hydrogen, I would then have to put a 4 here to get out this as an 8 as well to match up, and now we should be good. 2 irons on both sides, 8 hydrogens on both sides, 4 oxygens on both sides. We're balanced. Again, I could put a 1 here if I wanted to. I don't have to though, okay? Now the only other thing that I want to mention before I recap the objective is if you ever have all even numbers here, it needs to be reduced. Meaning if this was a 2 right here and these were 2, 4, 2, 4, okay, everything could be reduced by half. These have to be in lowest terms. But because really technically there's a 1 here, this can't be reduced, so what we have is correct, okay? So just as a recap again, you need to be able to understand that the valence electrons are what change when we're talking about chemical reactions. You need to identify that reactants are always on the left, your products are always on the right. Also that your reactants are probably not anything similar to your products. So a lot of different properties here. So again, iron and water is different from iron oxide and hydrogen gas. It's a lot different. And then also understand the law of conservation of matter by writing and balancing equations like you see here. Okay, so if you have questions, please let me know. Being able to balance these equations are definitely important, especially when you get to high school chemistry. They're expecting you to be able to do the really challenging ones of these. So please don't short yourself on practice of balancing equations. All right, good luck. Let me know if you have questions.